Okay, so if everyone can please take their seats again, we'll kind of get started with our next talk. I'm pleased to introduce Preston Doster. Preston is an senior engineering manager at Twilio, and he's responsible for Twilio's compute fabric and also our service mesh. And so Preston's going to talk to us about testing and production. So take it away, Preston.
Cool. Thanks, Justin. Everybody good in the back? I think so. I can hear myself. So cool. Awesome. So really want to frame this with this number, 5.5 billion. So this is how many API requests we hit last week, right? So thinking about testing in production at this volume, when we're hitting this volume, we have lots of opportunities to lose our customers' trust, right? We have 5.5 billion chances to do that. So when I say testing in production, I want to frame it with how do we do this really safely, right? Because again, it's all about customer trust. It's all about how do we keep our customers relying on Twilio. Oh, thank you. And we're not losing that trust. And really to frame that even further, so this is a graph of 2018 for us, and really API hits over time for the year. And you can see a really distinct jump around the November timeframe because there was the election, right? And what we thought kind of going into it was like, hey, we're gonna hit a really high number around November, right around the election, and it'll back off. It'll calm down and we can breathe again. But really what we found when you zoom in on that is we really established a new normal. The API calls didn't drop. I mean, you see that little dip right there, right after the election, but reality was growth just continued. So again, keep that in mind when I'm talking about testing in production. It's something that we need to do, but it's something that we do very carefully. It's not something that we do haphazardly, because again, it's about building customer trust. So at Twilio, as we've grown, we really fall back on our corporate values or our core values that we now call the Twilio magic. So one of my favorite ones is draw the owl, right? So again, in this context of like all these API requests that are just always hitting, how do we solve for that? How do we solve for this testing challenge that we have where we need to push changes to production and we need to push them safely, but at the same time, really with our customers earning trust through every interaction. This is another one of my favorite sentences in our Twilio magic is literally with every single transaction or interaction that we do with our customers, how do we continue to earn their trust? Because if we do that, then they'll keep coming back, right? They keep relying on us. So a little bit about the teams. Justin kind of introed a bit of this. So I'm part of the platform engineering team. We build further Twilions. So my customers are other Twilio engineers. We provide base compute primitives. So if you start thinking about the core building blocks or the Legos that are going to get composed into these like higher order services that service Twilio's customers, that's where we fit. So VMs, your AMIs, booting VMs, VM replacement, right? So like the most foundational stuff. Containers, what do your base images look like? What does Kubernetes look like in the Twilio world? How do people use Docker? And then ultimately, how do services talk to each other, right? So whether it's HA Proxy or Envoy, we'll talk a little bit about more of that later. How do services find each other, right? So how do we provide this fabric that the other customer-facing teams can build on to deliver these awesome services? So I want to start with the story to kind of illustrate where we came from. So this, I think, time frame for this is probably about 5 or so years ago. So we had a mission-critical platform system. So this is like the core system that would boot virtual machines at Twilio. So if this thing doesn't work, people don't get work done, right? Services don't scale up to meet demand. So we were seeing about 200,000 500s every quarter. I think when we calculate out the SLA, it was like tiniest bit over 99%. So 2 nines, pretty cool, doing really well. Daily incidents in dev, right? So again, if engineers can't boot virtual machines, they aren't building software, they aren't shipping software, they aren't moving things forward. And when we really looked at it, we needed a pretty serious refactor. There was a lot that we needed to do to make things safer. And in this situation, it can kind of feel hopeless. Feels like things are burning all around you, and especially as a platform team. And I've heard this as an actual quote, not here at Twilio, but elsewhere. Your dev is not my dev. As a platform team, when I ship something to dev, or when my team ships something to dev, it's really prod. Because again, if we're blocking engineers from shipping software, we're blocking the pipeline and kind of the lifeblood of the company. So we always have to keep in mind that that first ship to dev is really prod for us. So really kind of looking at what we needed, right? So thinking we've got the system, it's pretty much on fire, right? lots of 500s, need good integration tests, right? And all these things that I'm about to list off, these are all things that we know we need to do, right? We had pretty good test coverage, but again, like the challenge that we had is our unit tests weren't super real. They tested and executed the code paths, but weird stuff happens in production. We weren't accounting for all these different scenarios. You need really realistic integration tests, right? How are people exercising your systems? How are your customers doing strange things with configs, or like what kind of payloads are they sending you that are going to cause these weird conditions to happen? We really didn't have these great load tests. We had okay ones, like they were pretty simple, they were pretty straightforward, but again, they didn't really mirror real traffic patterns. So what we found is we thought we could hit one level, and in production it was something entirely different. We didn't have a great way to test hypotheses in prod either. So we didn't have canaries. We didn't have isolation of our different customer bases, if you will. So we would put it in production, or we would put it in dev, right? Again, because dev is really broad, and things would blow up. And ultimately, like what we really, really, really wanted was how could we get like copies of the actual requests coming in and mirror that or shadow that, and again have a really safe place to go test those hypotheses. So again, this is mission critical system within Twilio. This is kind of where we found ourselves, is we're missing all these things. For the concept of this talk, I really want to really focus on these areas, right? Because this is really where we found ourselves leveling up. And ultimately, like the question kept coming back to is how do we make these tests more real, right? How do we make this really feel like real production, so that we could find things before our customers found them? Because we always found ourselves in that loop. And ultimately what it came to was really us just deciding how much risk we wanted to take, right? Because I say testing in production because we test in production. But that means real customer traffic. That could mean other engineers not being able to do their job. So we had to figure out like what was that level of risk that we're willing to take when we do a show. So we started looking at our risk pools, right? And so you see a nice little gradient, green, super safe. Red, not so safe. So safest is probably your team, right? So if we ship software to our team and we break it for ourselves, not that big of a deal. Go fix it, right? We impact our little sphere, right? Going up from there, load tests and stress tests, synthetic transactions. These are things that are intended to find issues. So again, if you ship software and these fail, that's kind of a good thing. You get good feedback early on. Kind of moving up, again, we're a platform team, so we ship software for other Twilions. If we break it for them, it's not a great thing because it starts to impact their work. Same thing for other platform tools. So even though I'm in platform, my team ships software for the other platform tools as well. If we break them, then again, the blast radius starts to increase. Now we start to get to the real external risk, right? So we have customers, but we have different levels of customers. We have early access customers. So people who expect to get early software and they expect to maybe run into a bug occasionally, or maybe have an outage every once in a while. Beta customers, same thing, but maybe not as tolerant to outages. GA customers, they expect 5 nines, or they expect whatever SLA they've signed to. And then ultimately, some people may have life and safety critical workloads, right? So think like 911 services, medical services. These are the things where you're looking for the maximum uptime, right? Because really bad things happen if these services go down. So we take these risk pools and we start to form them into, at Twilio, what we call stacks. And stacks are really, at the most simple, they're a label, right? It's a word. It's a word that you assign to things. And by assigning those to virtual machines or different resources within our infrastructure, we create this stack of connected services. And it starts to look a little like this. So here I've got a representation of 3 different stacks. You'll notice that I've got app A, B, and C in each of the stacks. So we deploy to each of, copies of each of those pieces of software to each of the stacks. And then they're interconnected such that, app A in this purple platform engineering stack would talk to B and C in that same stack and never leave that stack. I said never, but there's a little asterisk on that, and we'll talk about that. So routing labels. So like I said, we've created these labels for our different risk pools, and now every host or virtual machine in the environment gets assigned one of these, right? So you're always pinning into one. And the contract, like I said, is if you're in a stack, you keep it in the stack. Asterisk. And then ultimately you're using these headers and these labels to make routing decisions. So when you go from app A to B to C, that's really directing the flow of your traffic. And at Twilio, we've come up with this shared understanding amongst teams called the service header standards. And the idea is that when you receive this set of headers, T canary, T stack, you will pass those headers on, right? Because at the point that somebody doesn't do that, you've broken the contract of the stack, right? You don't know where to go route the traffic. And you're starting to defeat the purpose of why we have these vertical integrations. So here's an example. So this is a call to our internal service discovery system. And the response, I've truncated it slightly because it's extremely verbose normally, for a host, your label, this particular host is in the green stack. It is not part of the canary fleet. It does not have a fallback stack defined, and it's in the US East 1E availability zone. So we use all those when we decide where to send traffic downstream. And we'll get into more of it in just a bit here. And an example of actually using that at runtime would be just a curl call. Here's a curl with T stack of red. I want this call to go into the red stack. So service discovery is a huge piece of this as well, right? Obviously, as illustrated by that last example. So how do you find the next node in the hop? If I'm going from A to B, how do I know which virtual machine to call? DNS alone is not going to give this to us, right? So it's not the same as if something is in or out of load balancer, right? Again, DNS by itself is not good enough. Load balancers by themselves are not good enough. They need more information. Ultimately, when you're calling into service discovery, you're going to use that stack as a filter. You'll say, hey, where is app B for the red stack? Give me that list of nodes back. And ideally, this is transparent to your application logic. This shouldn't be something that developers worry about. It might be an external library. It might be a service mesh, which we'll talk about in a moment. It's some other connective tissue or some other glue that's helping your applications find their downstream services. At Twilio, we have a piece of software called Cartographer. It's effectively the atlas for where is everything in the world. And then when you want to find it, you call into Cartographer to get those query results. So now to really tie it all together, I mentioned connective tissue. So how do services now start to talk to each other? I can find other services. I can find other services in my stack. But what actually makes that call happen? We're combining everything that we just talked about with service discovery. What are your node conditions? So is your virtual machine running? Is it connected to the network? Is it pingable, right? So like those core vitals. Your service conditions. What's the health of your application? Is it able to connect to its database? Is it passing its health checks? Are all of those green? And then ultimately that routing label. And all of those put together form that decision to say, I might send it to this node. Key to this is as those conditions change, you're dynamically regenerating your config. Right? So if we're talking HA proxy, if something in the service discovery world changes, we hup and immediately regenerate that HA proxy config. For Envoy, we use our control plane to then go push an update to the Envoy config. And again, I've already started talking about HA proxy and Envoy, but those are like the two core pieces of software that we use to connect services to each other. So now to really illustrate this, looking at what dynamic config looks like. So if we were to tail the HA proxy log, and when we get to the demo here in just a bit, this is what it might look like at a point in time. Right? So we can see here that we've got one backend for this orc autoscale test server API. Right? We've got two nodes in the load balance pool. What we should see a bit later when we look at the demo is as we change the membership in the stack, we should see this config get re-rendered, right? The node should change. And then ultimately that should change the output that we see when we call these downstream services. All right, so to go a little bit more into the mesh, so this is specifically how we're orchestrating or how we're building out Envoy. So you have two sides to it, upstream apps, downstream apps. And just to be very clear, we call them different things than what Envoy calls them. Envoy actually flips it around. But your upstream app would be your consumers. So if I'm this app here in the middle, my upstream apps would consume my service. My downstream services are the services that I consume. And you can see here we've got the Envoy agent in the middle. And it is essentially the proxy between all of those different communications. And the reason we do that is, there are multiple reasons that we do that, right? Key thing is, as new features come out in Envoy, we can start to take advantage of those, right? And we were just talking about like progressive adoption of features over time. our customers in the platform can opt into these different features when they're ready for them. Because day one, not everybody's going to be ready for traffic mirroring, right? But maybe in a year they will. But almost everybody can take advantage of circuit breaker patterns or timeout patterns very early on. And we expose those features through this control plane, right? That's responsible for managing the configuration. All right, so at this point, we have labels, we have service discovery, we have the mesh that's between all of our services. So now we can start stacking things. And as mentioned earlier, we apply a stack label based on that risk pool, right? So, and this is an exercise that your team can go through where you look at those pools and you say, hey, maybe 2 pools are fine. Maybe there's an early access and a GA pool. Maybe you need 8. It really depends on, again, how much risk are you willing to take? So for example, red stack for customer critical traffic. The things that go there have to be tested, battle hardened and ready. Yellow stack, platform services, things that, if something bad were to happen, we wouldn't be super happy about it and we'd want to fix it pretty quickly. Green could be test fleets. We expect things to potentially go wrong here. Experimental software, right? In the spirit of, shipping early and often, but safely, this is what could fit into that stack. On top of that, within each stack, we have the ability to add a canary. So release an update of that software to a limited set of hosts within that pool, right? So again, if we're separated into 3 different pools, in our most critical red stack, we might still have a canary. Again, just to be absolutely sure, and progressively roll that out until everybody has that software. And ultimately, you're using your app logs, any kind of an anomaly detection, your gut, right, to determine if it's time to go push, right, to the full stack. And with the way that we've built things at Twilio, we actually allow the upstream apps to decide if they'll allow or tolerate a canary downstream. And then ultimately, you end up coupling this with retry logic. So I mentioned like circuit breaker patterns. So if you're opted into a canary, let's say the canary call fails, using service mesh, you could still then reroute that to the live portion of the stack, still maintain your success rate, right, and the integrity of the overall call, while still getting that opportunity to test and really gather information. And then finally, mirroring and shadowing, right? This is kind of like the top of that hierarchy of needs, right? This is how you make it the most real, is ultimately you take a copy of the initial request on your edge and you route it to a completely different stack. And at this point, and what's nice is it doesn't affect your main transaction, again, depending on the software that you're using. In Envoy, you have the ability to make that copy, discard the result, right? But then you can pass it all the way down a replica of your actual production stack. It could be 1 for 1, just depending on how far you want to go. And you can really safely test that hypothesis, right? So, and ultimately, the limit is infinite. You could seriously create the exact copy of production all the way down to your data stores, all the way down to queues and everything, and really test out how things go, right? And really know. And ultimately, this is another example of what it might look like, right? So here I've got 4 different stacks. I've got what I would call this safe sandbox. So this is like the green side of the scale. And then we have live customers. So those are like our 2 major pools. Within the sandbox, we would still do our normal build cycle, right? So we're still running all of our tests. None of that changes. This is additive. We would first do a release to our canary in the safe sandbox. Again, bake it for a while. Make sure things look good. Watch the metrics. See if there are any anomalies out there. Run load tests. Run chaos tests. Whatever we need to do to go get some information in our sandbox. Then go push it to live. Same cycle, right? Continue to gather information. Just really tighten up that feedback cycle. Ultimately, we then push it to that live pool, right? And we follow that same pattern all the way until we're at our most critical, highest risk pool. But at this point, we've tested so many times that we're absolutely sure that we're going to honor the trust of our customers. And then finally, we push it to live, and 100% of people have. Yeah, I don't know where this is coming from, but so ultimately, again, I come back to this owl not only because it's like a totally sweet picture, but because it sounds like it's the TV. But yeah, so ultimately, it's about earning trust with every single interaction that you have. And again, framing it in that context of 5.5 billion API requests a week, we have that many opportunities to improve our customers' trust and keep them coming back. So cool. So that's pretty much what I had. I've got a demo. If we can figure out the beeping thing, it's somewhere. Boom, got it. Excellent. You fixed it, Dan. Nice. Cool. So I'm going to run through a quick demo, really just illustrate the different concepts. So this is going to be super live. Let's see if I can hit exit here. Okay, so first thing I want to show is, okay, so this is, okay, great, everything's there. This is our single pane of glass for our platform that's called Admiral. Admiral is where the majority of engineers will go to actuate deployments. If you want to push to dev and then promote all the way through prod, you come into Admiral. So here I've got a test role. So this would be that downstream role that we were talking about. So this is the server that's hosting an API. And in this case, I've deployed out 4 different stacks. So I've got this first stack here that I've called default, because I couldn't come up with a better name. It has a version of the software that doesn't have this update that we're going to go test. And then I've got a red, yellow, green set of stacks that do have the update. And then I've also got another application that's just a client role. I'm going to SSH into it. Hopefully my connection or my VPN didn't drop and it's still connected. Okay, cool. And we're here. So this is really just a split of 2 different commands that I'm running a watch on. On the top side, we're looking at the HA proxy config on the client server, right? So both of these are on the client, looking at the HA proxy config. On the bottom side, it looks like I broke something, so hopefully we'll fix it here in just a second. But this would be the call to the downstream server. Again, so this is the set of 4 stacks that I have. Right now, we're calling into the default stack. And let's see what happens when we start changing some of these different labels on the host. So now I'm going to go into box config. So box config is probably like one of the lowest level systems that we have. It's responsible for booting VMs and changing attributes of those VMs. And so what I'm going to play with here is really just this stack label. Again, to illustrate that concept of these different levels of isolation. And what I'm going to change is let's start by just saying the stack is green. And this is from my client server, right? So now what we should expect is, because we have these different vertical isolations, when we flip over to there, we should see 2 main things. So first thing is, you can see HA proxy config has changed, right? So we now have 2 backends in our load balance, or 2 servers that we're going to call in our backend in a load balance set. And then on the bottom here, as we're curling into that downstream, you can see first thing is the host SID, which is just our unique ID. See, that's changing, right? So we're just doing a round robin load balance. You also see that the stack is green, right? So we're hitting those 2 green servers. So now if I flip to red, what I hope will happen, or what will happen, is we'll now start to see, again, the HA proxy config is updated. We're now calling into that red set of servers. Again, the server is self-identifying itself as red, and you can see how now, again, it's flipping through 2 different host SIDs. So there are several other features we have as well. So there's a notion of a fallback stack. So that asterisk that I talked about, where it's like we never exit a stack, there is the concept of a fallback. So in the event that for some reason a downstream isn't available in your stack, you can fall back to one other stack. And what we could do here is, let's say the fallback stack is the green stack. I'll go ahead and save that. That'll get pushed out. Now, at this point, we don't expect anything to change because we can still hit our servers in the red stack. If I were to go back now, and let's do a quick refresh, if I were to change this stack to something that doesn't exist, like chartreuse, because I don't think I had that stack. Now what should start to happen is, notice, so that chartreuse stack doesn't exist. There are no servers there. You know, when we go look at service discovery to go see that, service discovery will turn none. And then HA proxy or Envoy would automatically say, now we should move to the green stack because that's the fallback. So this is a really simple example of that stacks concept illustrated. But this is something that we use throughout the Twilio stack, right? So whether it's the customer, the Twilio customer facing teams or whether it's the platform teams, we use this to isolate those different risk pools, right? And make sure that when we're pushing software that we are earning trust with every interaction. That's all I've got. Questions? Oh, yeah, or you can clap, whatever. However y'all want to do it. Cool, excellent, yeah.
Do stacks include every service, including like your data storage tiers?
Yeah, absolutely. So it's team dependent on how they use the stack. The recommendation is yes, including asynchronous stores or like transient stores. So if you have Kafka streams, any kind of event bus, you're tagging that all along the way so that when you're popping something, say, off of a queue, that it continues within that stack.
So what's the qualification criteria for moving from one stack to the next stack? And is that automated or like how does that work?
Yeah, so I would say in general, it's not something that happens often. So I did this mostly for illustrative purposes, just so we could kind of see what it looks like for things to move around. Reality is we generally treat infrastructure as immutable. So once your virtual machine's deployed out there and it's tagged, it stays within that stack. Yeah, and it would be more a conscious decision to like reorganize stacks as opposed to like somebody being like, oh my gosh, we've got to move to the red stack right now.
How do you deal with logical errors in data? So if you have a fallback stack, you push data in a write operation, it falls back to the green stack, but your read operations are still like going to your red stack and the data is not there any longer.
Sure, yeah, so that would be again, kind of like a team dependent thing where they would need to create whatever their remediation plan would be for that. Generally like fallback stacks, I would say are probably gonna be less around like data stores. It's gonna be more around just transient paths.
You're doing this gradual rollout across stacks with different levels of expected reliability.
Mm-hmm.
How long does it take on average to start from a change? Assuming that the change didn't have any bugs, like it's healthy, how long till you like mature it and graduate till the very end of like highest critical systems?
Yeah, so unfortunately the answer is it depends. And it goes back to risk pools, right? It's who are you deploying to? What is the service that you're deploying? So an example might be like this box config service, right? It's that kind of core virtual machine orchestrator. I would say on average, like we would probably push over the course of an hour.
Of course, what, sorry?
Over the course of an hour for this particular service. Now, there might be voice roles, right? So like think like core voice applications within Twilio that may take longer than that, right? They might take days. Ultimately, it's kind of dependent on the team. It's dependent on how core the function is and the number of stacks and the customer populations they put in those.
Makes sense. Next question, which is kind of related to this, which is, let's say the happy path didn't happen and you discovered a bug and you're like pretty high priority stack. Mm-hmm. And do you have like organizational practices and recommendations on how do you roll out a change to high priority stack, which is a change that fixes already existing functionality, despite lower priority stacks being like a different version. Like do you roll forwards? Do you roll backwards? The other stacks, and like you
I would say
roll sideways.
It's going to be like a team and situation dependent thing. It would depend on like, to me, like here, this would be my call is like, let's say it's box config and we discovered that. It would depend on the size of the change, right? How sure are we of the change? How quickly would we want to roll it to the other environments as well? But yeah, it's kind of another one of those TBDs where it's like, it depends on the risk pools and how we're going to go treat those customers. Yeah.
Thank you.
Mm-hmm.
Great talk so far. Debugging tools. So I imagine that as you introduce all these different stacks, one of the challenges developers will have is like, oh, I forgot I was in the green stack or the red stack. How do you ensure and like that it's very obvious for engineers? Like, or do you not have this problem as they start debugging their services?
I think that's always a challenge, right? Is like, you don't realize hey, I was SSH into this and I don't know where I was. Like for us, again, like kind of going back to Admiral, if I'm still presenting, we take the opportunity to make it obvious, like where, like contextually where you are. I would say, like, again, if you're SSH'd into a server, you have the opportunity to see what stack you're in, but it would be up to that engineer to realize it. So right now, I wouldn't say that we have like specific things around it, beyond just like lots of labeling, lots of, be aware of your surroundings kind of setup.
So, sort of follow-up question from what he asked, like how do you manage different versions of the code? Because technically I'm assuming each service has its one code base and it may be deploying to different stacks based on what they're actually trying to add as a functionality or bug fix. How is that managed from an orchestration perspective?
Yeah, so I would say that's a huge question. I feel like I continue to evade the questions by saying it's team dependent. So one of the principles at Twilio is that we're really focused on small team enablement. So from a platform perspective, in a lot of cases, we put the tools out there. So again, so Admiral, so box config, stacks, and it's up to the team to then go assemble it in a way that fits their particular service. But in this case, I would say it's going to be a combination of how does that team, do pull requests? How do they branch? How do they ship different and label different artifacts? Do they release to a stack from a branch? Do they, there's so many variables that could go into play there. What I would say is I can speak from like, again, box config. In general, we're pretty much like at the point that we're going to dev again, because dev is prod, it's a release off of master, right? So it's a clean merge. We've done our internal testing, and then that's what gets promoted through. We don't necessarily, except in the case of like experiments, like we're generally not releasing off of a branch into what we would call a prod-like environment. Again, that's my team. Many other teams can go do things differently. So I don't know, Jeremy, what do you do?
I'm happy to be one of these customers on the platform here. So the way our team works is, generally speaking, you have the software that gets deployed, and the deployment stays static for the most part because that software is on the host. Now, when we go ahead and redeploy later on, we're going to go ahead and probably take the latest and greatest, but that's our choice entirely. There's no prescribed way of doing this. We're always just like, yep, all right, time to roll up to the latest AMI or the latest internal configurations, and basically, because while they think that dev is prod for them, dev is just our playground. It's our sandbox. So if we're getting deployments that are going successfully in dev, well, we still have dev stage prod to roll through ourselves. So we have a whole validation process where our team is going through outside of whatever they're doing under the hood.
If I was to guess, at some moment, the stacks start sharing infrastructure. Like, how far does it go? Like, do stacks run their own, like, some kind of logging? I don't know, whether you Splunk or something. Do they, like, run their own AWS instances or AWS accounts? How far down do the stacks go?
Yeah, I would say, again, team dependent. Now, so I've seen it go as far down as, so the different risk pools are essentially shards, right down, all the way down to like a data store. I would say sometimes you might see shared AWS accounts. But again, that all goes into like the risk analysis where we would take an informed decision that says, hey, this is super high risk. Like, let's say it's like PCI compliant or something. This needs a different level of isolation. So the stacking or like that vertical stack goes deeper than maybe something that's not as critical.
And I guess this means that you have some kind of orchestration across AWS accounts that's able to like make judgment calls around them and do like management chains to them.
All right, I guess I don't follow. Across AWS accounts. Yeah, so platform components may be shared across stacks, right? Because I would almost look at it as if we provide a service, almost like AWS does, right? Where AWS provides a service to us, it's black box to a degree. Same thing for platform services.
Yeah, so what services are considered platform services in this world? that they're shared?
Oh, sure. So like the example would be like box config, Admiral, our API edge that we call Battlestar, right? So the main entry point that they use to then go actuate different changes to the environments, that would be like shared platform components, build systems, packaging, repositories. All those kinds of things fall within platform.
Thank you.
Mm-hmm.
So I'll try to word this question so that it's not team dependent.
Good luck. I'm really good at answering with that.
It feels like there's an opportunity as a platform team to really pull out metrics and provide reporting and insights for teams to say, hey, it looks like in your progression from default to red to yellow to green, you have like a higher than normal, rate of failure in yellow. And how do you take advantage of the metrics and provide reporting on this to let teams know maybe where they might have some optimizations in their testing processes?
Absolutely. So we have a team that's focused on like what we call resilience. And that is part of their core mission, is to start to identify, given that we have all this great data. So yeah, all this stuff is in Datadog. It's stored in log aggregation. How does a resilience team effectively find like insights across that? And that's an initiative that we invest in for sure. So yeah, definitely huge opportunity. No specific tooling around it yet, but it's something that we're working towards. Mm-hmm.
Any other questions? It's fun. It makes your voice sound really loud. You can try it.
So do we have different standards for the headers that are being propagated across different stacks? Or like when we're having different stacks, I'm just assuming that might be an issue, right? Like a way of identification, basically.
Yeah, so I made reference, I could probably bring it up, but there's effectively like a service header standard that's owned by our architecture team. And that dictates like the musts. You must pass X set of headers to your downstreams. And then shoulds, and then other things would be optional that would be team dependent. Trying to find a way to say that in every single answer. But yeah, but the service header standard is essentially like the global contract that all teams at Twilio must adhere to. Mm-hmm.
All right, let's give a hand for Preston. Thank you.